Hi everyone, welcome to our event. This event is brought to you by DataTalks.Club, which is a community of people who love data. We have weekly events. Today, as I said, this event is rather unusual. It's not in our usual time. But if you want to find out more about the events we have a link in the description. Go there, check it out. And today we have one more event. In a couple of hours, we will have a session about Kubeflow pipelines. It will be a workshop, so check it out. Kubeflow and Kubeflow pipelines in general. And we have other awesome events, so check the link out. And of course, if you have not subscribed to our YouTube channel, now it's the best time to do this. This way you will not miss our future events that will be as awesome as this one. We have a Slack community, so you should join it if you want to hang out with other data enthusiasts. And during today's interview, you can ask any question you want. There is a pinned link in the live chat. So go there, click on that link, ask your question, and I will be covering these questions during the interview. And just in case, I will also open now this stream on YouTube on my phone. So if you ask questions there, I will also see that. Okay, with that, I think I should just stop sharing my screen. Open the questions we prepared for you, Arseny. And yeah, I think I'm ready. Are you ready?
Of course.
Okay, you're ready. So this week we'll talk about building scalable and reliable machine learning systems, or we can call it machine learning system design. We have a special guest today, Arseny. Arseny is a machine learning engineer who is working on machine learning projects since 2015. He mainly focuses on deep learning and MLOps related problems. This is not the first time Arseny appears here. So he previously gave a talk maybe 1 year ago about software testing for machine learning pipelines. It was actually quite well received, so thanks a lot, Arseny, for doing that. And it's a great pleasure to have you a second time here. And also,
likewise,
for those who don't know, Arseny for some time has been working on a new book about machine learning system design. So we wanted to invite him to talk more about that. So welcome to our event.
Thanks, Alexei. Great pleasure to be here.
The questions for today's interview were prepared by Johanna. Thanks, Johanna, for your help. And before we go into our main topic of machine learning system design, Arseny, let's start with your background. Can you tell us about your career journey so far?
Yeah, sure. I've been doing machine learning for a while, and I usually work for startups. I used to work in some big companies as well, but I realized that startups is more preferable area for me because, well, that's usually places where I can have a reasonable impact with my skills and my personality. So for the last year, I've been working for the company named Entropy. Entropy has been applying machine learning and language models for financial transactions and extracting some information from it. Before it, I've been working for Instrumental. Instrumental is a manufacturing optimization company, as I said in our pre-show. Before Instrumental, I've been working for AR company that has been recently acquired by Farfetch. And even before, I've been doing machine learning for a ride-sharing company that was acquired by Lyft. So many startups. And that's kind of background that I wanted to express in the book.
Mm-hmm. And this AR company that you mentioned, I think there is quite an interesting application there. So it's about trying like how shoes would look like on you, right?
Yeah, it was a virtual try-on. We started with a very small niche of nail polish try-on. And later we started working on jewelry, like rings. And at some point we understood that, well, rings is probably a very specific niche as well. Like what was the problem with nail polish? This is a very small market, and there are not many companies who are ready to pay we were going to have a B2B application, like selling SDK to companies who are interested to embed it to their applications to improve conversion rates and stuff. So didn't really work out. And at some point, we have found a company who tries to build it for virtual try-on of shoes, and their tech was actually far from perfect. And we as a company decided, well, we can do better, and we did better.
So the idea is that you take your phone, then point it to your legs, and then you see how your legs would look like with shoes?
Yeah, with various sneakers, like if you consider buying some fancy new collection by Nike, but you are not sure if it fits your style or not, that's what you can do. So we had a consumer app just for personal try-on, and we had an SDK that was integrated by big companies.
And as a machine learning engineer who has worked in many different startups, I guess for you it was pretty typical that in all these companies you don't really have anything for machine learning models, right? So you have, I don't know, a data scientist who comes up with a model, but then what to do with this model, right? So how do you serve this model? How do you design the whole thing? Like how do you actually productionize the models, right? Was it something that you observed in all these companies?
Yes, that's right. Sometimes people, when working in big companies, they already have some kind of template. They have a relatively small space to explore. Like, well, you just do what people do. You don't need to make many design decisions. Like, you don't need to choose tech for everything from scratch. When in startup, you have to make all the decisions on your own. Or with your small team, and you have to find some kind of trade-off between building reliable, scalable stuff with all the bells and whistles, and from other perspective, you need to make everything ready ASAP, like yesterday. You don't have much time. So both ends are not very healthy. You need to choose something reasonably good, okish, acceptable for an acceptable time and resources.
Is this what you would call machine learning system design? Like you have a machine learning problem or I don't know system, and then you need to design it in such a way that it's both reliable but ready as soon as possible. So you kind of satisfy what you just mentioned, right? Because like in a startup, you need to move fast. You don't want to spend a year building a machine learning platform, right? Or machine learning system design is about something else.
I would say machine learning system design is about making decisions how to build a system given some constraints. And while saying given constraints, they exist, but you don't know them in advance. So when you are some kind of junior engineer, you usually receive your tasks in your task tracker or directly by your lead or manager. And you are being said, you need to implement this method. You need to write this class. You need to train this model. Very straightforward. When you are like some middle level engineer, you have more freedom and you start making your own decisions, but your area of decisions is still relatively small. But when you are in charge of bigger systems, and when working in startups, you become in charge of these systems very early. You don't have a senior principal data architect who will take care of everything. You just have this problem. You have a co-founder who says, well, we need to build it. We have some ideas, blah, 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 but you need to build it. And it means that you have to make many decisions and you need to explore the world trying to find all these constraints, or at least the most important constraints, and make your decisions what you should do how much effort should be dedicated to this or that stage, given these constraints and requirements. When saying requirements, I don't mean something like very formal, because in huge enterprises, when we talk requirements, it's a big document written by a business analyst or system analyst or product manager or whatever. There is a chance you work in a company where there is no product manager at all, but requirements still exist and constraints still exist. You just need to catch them out of air.
And I'm just wondering, what are these constraints and requirements? Like, do you have an example? Because you mentioned that you don't necessarily know them in advance, because I imagine that if you work in a startup, then maybe there are some requirements coming from your product manager or CEO, whatever, like that we need to ship this thing in 2 weeks, right? That's kind of one of the requirements, I assume. But what are the other constraints and requirements that you don't necessarily know in advance?
Okay, some of them are purely technical and some are product related. When we are talking about purely technical stuff, you can expect that your stuff is gonna be run on specific hardware. So for example, we were talking about this AR company, and I think I can bring many examples from this one because I was an early engineer there, and many decisions were made with me and my peers at this early stage. So for example, we decided that it is a mobile application. And for mobile application, work in real time on video stream, we definitely cannot afford to have some heavy machine learning models. And we cannot afford calculating them in the cloud. So it should be on edge devices. And it's a significant constraint. You cannot run like 1 gigabyte convolutional neural network on this device. But from other perspective, we decided that we start with iOS devices. And Apple infrastructure is ML friendly. And it was ML friendly back in days when we started this project. Because there is Core ML. Core ML is fairly optimized for this hardware. We were working with iPhones like, I think 10, like iPhone X, and it was good. Porting our software later for the Android was a huge pain, but for the beginning to build some demo app, iPhone is good enough. So we understand, given you know the hardware, you can understand what you can do. Like, okay, 2 big networks is no, but deployment in general is fine because, well, this ecosystem is deployment friendly. And from other perspective, there are some requirements about how we expect users to perceive this product. Like it's at the very beginning, we realized that if this rendered shoe that we draw on a screen is shaking because of some instability of our model, that's not good. It annoys people, and users are gonna say that that's not acceptable at all. And we also realize that if our models are heavy and consume all the CPU, all the GPU, it also means it consumes a lot of energy, a lot of battery, and users definitely will not be happy about sucking all their energy in a minute. So that's another constraint, and it means even if the phone can run this neural network with 30 FPS, it doesn't mean you should do it. Maybe you should do something like run it 10 FPS and interpolate it with simpler algorithm in between frames just to save some energy, and the phone will not get in hot. So that's not a very like straightforward requirement, but when you start working with mobile inference, you understand it relatively quick.
I wonder for all these things, like you cannot afford sending data over the network because you need to have this real time. Like you need to know about these things in advance before you even start training your model, before you start, I don't know, collecting your data. Because otherwise, like if you don't know this, then you end up having a heavy model that doesn't really work on edge, right? It always has to be like I don't know, maybe there is this design phase of a machine learning project where you don't do anything but just think about the problem, right? Or how is it done in practice usually?
Well, that's, as people say, there are known unknowns and unknown unknowns.
Yeah, right.
So you can maybe try to mitigate the first one. You talk to people who have been doing something similar. Like we had buddies who have been doing very complicated deep tech ML-based project for mobile platform. And we talked with them a lot, and they warned us about many things, like both high level and low level. High level, as I mentioned, about this FPS stuff and that users care about stability of the rendered object, and about low level, like when designing your model, be careful about this particular layer because this particular layer is not optimized for this architecture, or this activational function is not optimized as well. But if you do this one and this one, you can merge them together and it is run by a single pass on GPU, and thus it is very effective. So these are tricks you can learn in advance if you have people to discuss it, and you can do some early tests with a very dirty baseline and so on and so forth. So it makes sense to make something with a simple baseline and try this simple baseline on your own, maybe within your team, within some of your friends, to understand how it can be used. And it reveals more and more hidden knowledge, more and more unknown unknowns become things that are known unknowns. Like, well, you are not particularly sure what's going on here, but you reveal some parts of it. And with this application, for example, we released one of our earliest versions, and we have found the problem related to reflecting surfaces. We expected that users will have just their legs, but sometimes they did a photo or shoot a video near the mirror, and this we had 4 legs instead of 2, and we did not expect it at all. And the algorithm was not supporting multiple heads, and there was sometimes some crazy show of a shoe jumping from the real leg to the reflection of it. It was hard to catch.
So, like in this case, you said there are known unknowns. You can get them, you can learn about them by talking to people with experience or doing some simple baseline and check how users react. But then there are unknown unknowns that the only way to find them out is just to roll this thing out and see what happens, right?
Yes, and actually writing a design document or something is a way to transform some unknown unknowns to known unknowns. Because, well, you cannot predict everything, especially when you are doing something pretty new, which is common thing for startup. But when you try to write down what you're going to do, it often reveals what you don't know about the thing you're going to build. It reveals some lags between components, lags of understanding of the domain, and so on and so forth. So even for startups that often work in a manner, screw it, we should just build it. At some point, I realized, well, it makes sense to spend a bit of time for planning. Not too much, but at least something. And that's not because you have to follow this plan like exactly line by line. as people say, plan is nothing, planning is everything. And that's exactly what I like about design phase. Well, okay, maybe you will not follow this design document exactly, but it will reveal many things, and understanding how you're going to build, I think, is more important than actually following this exact paragraph.
Yeah, I guess because it kind of forces you to learn more about the problem. It forces you to think about different situations. Otherwise, you wouldn't just think about them when just blindly thinking, let's just do it and see what happens. So speaking about this design document, how does it look? What kind of sections are there? Is there any structure? Like, let's say let's suppose I'm a machine learning engineer. I'm joining a startup and they don't have anything there before me. And I want to make things right? So there is a new project and I want to make sure I follow, best practices. So what do I do? How do I approach this design phase? How do I structure this design document?
Right. It's a tricky question because in big companies, there is something like a template, but for startups, there is definitely not a thing like template. And in this case, I prefer to say template doesn't really matter. You just start with whatever. You take just a sheet of paper and start writing stuff, or you open a Google Doc and you start writing stuff. One heuristic that I have in my mind that inexperienced people tend to start with solution, but you should start with a problem. And if you would like to spend, I don't know, 4 hours writing a design document because you don't have more time, and you would like to make a 2-page document or even 1-page document because your system is very simple, dedicate 50% for the problem and the rest for solution. Because solution is usually more straightforward when you know the problem, but it is a very easy mistake to ignore the real problem, which is complicated, and start building a very good solution that does not address the problem itself.
Is there any framework that can help me approach? Let's take the first part. So you said spend 50% of the time, 2 hours on defining the problem, and then the rest of the time, the other 2 hours on describing the solution. So what can help us describe the problem? Because to me, it seems like it's kind of straightforward. You just go there, spend 10 minutes describing what exactly this product people want from us. Like, okay, they want to build a system for automating this, or they want to build a system for trying sneakers on, right? So that's the whole problem, right? So why do I need to spend 2 hours on that? Like, what kind of questions I need to ask myself to help me come up with a good problem description?
Well, as we discussed earlier, there are things that are purely technical and there are things that are more product-wise, and you can split the two. So definitely some things are about appearance here, and you can talk to product people like, how do you expect users to, what is the user scenario, what users care and what they do not care about. We are talking about hypothetical users, so it's all not set in stone. You should take everything here with a huge grain of salt, but still. And you can get some first insight, like, do you want it, for example, in this AR problem, there is often a trade-off. Do you want it to look realistic, or you would like to look just, I don't know, a billion? And they're not the same. And if you are going to build a virtual try-on, which is exactly try-on with a goal to help user understand if this particular item fits, you should prefer realistic system. But if you just want to make an entertainment application, like these videos will be posted to TikTok and Snapchat. Definitely, you don't care about them being realistic, and you want them to be fun. So this is a trade-off you don't know about usually, and it takes some time to reveal this problem, some conversations, and so on and so forth. So you ask questions, you do assumptions, you verify these assumptions, and given some more, how do I say it? Given this pure product related thing, you should make some connection to pure technical things. Like, okay, they say we would like to have it real time. What does it mean real time? Because, well, something that is felt like real time for a user, as I said, it could be either like 30 FPS in reality, or it could be like 10 FPS with interpolation or 20 FPS with interpolation. And what are the devices we are going to run? What are the, for example, how many models we would like to embed? I mean, models of shoes that can be tried on, and so on. So definitely for any complicated problem, you can always spend a couple hours trying to understand what you need to build. What is good, what is not good. I don't know some good framework, and as part of this book, we are trying to build one. It always matters what is the problem, and I don't think we can build something that holistic that covers everything, but we try to cover many situations and describe what you can do in different scenarios. One more heuristic that is included in our book that I would like to mention here, given the question, is setting non-goals is a good technique as well. Like it's always tempting to say, well, we need to do everything perfect, but you cannot do everything perfect. And you cannot say, this is important and that is important, and also this one is important. Like if you'd like to have a model that is fast and accurate, and also it's easy to build during 2 weeks, that's not very realistic. So you can choose what you don't care about, and you can choose what to sacrifice, because most decisions are actually trade-offs. And you need to understand what is the surface of this landscape, what are the spectrums where you need to put this single point on this trade-off and say, well, okay, if we are going real time, we care about performance more than just time to develop this thing, because definitely you cannot build real time too fast. And if we are going to be realistic, we should care about exact matching of this photo to other photo, and later it will be reflected in our metrics and losses. But we do not really care about these images being just aesthetically appealing.
Okay. So in summary, in this design document for the non-technical part, for the problem description part, we should include goals and non-goals. Then we should include all the assumptions we have. I guess like assumptions could be how exactly users will use it, right? Or like other things. Then technical limitations. And also the user experience, like what the part of the flow where it will be used. Like, for example, user will take a phone and point towards the legs, and then what should happen exactly, right? So this is all like problem description. Am I right?
Yes, I would also add that there should be some points that later will be transformed to metrics. Like how do we decide what's good, what's not? Because when you draft the solution part, you definitely would like to have some metrics. So what is a good solution, what is not? And when you have no objectives that you can measure, or at least imagine how you can measure it. Maybe not right now, because for example, this aesthetic appealing is not a thing that is easy to measure. But when you just write down, well, we would like it to be aesthetically appealing, that's the problem. And in the solution part, you can think about how you going to measure it.
Like could be simple things like, I don't know, we add a feedback button to the screen. And if something goes wrong, users can give us feedback and then we see how much negative feedback we get, right? Could be one of the metrics.
Yeah, definitely. So it's a very, very earliest stage. You measure aesthetically this aesthetic property of your pipeline on your own. You just look at it and say, no, I don't like it. That's my metric.
Mm-hmm.
Later, you introduce some human feedback. You introduce some platform for A/B testing. Like you, instead of just you looking at these images, you ask your peers to look at them. And later you ask some external evaluators to look at them. And later you receive some feedback from end users of your platform. But it's still a cascade of very similar things.
Mm-hmm. Okay, so for the design document that we talked about, there are two parts, the problem description part and the solution description part. So for the problem description part, we more or less already talked about this. So here, I guess we need to sit down with product managers and try to get as much information from them as possible. Also, perhaps we need to spend some time with our engineers. I don't know, mobile engineers, for example, in this case, or I don't know, some other engineers who can help us identify all these technical limitations. And we write down all the assumptions. So we come up with, I don't know, one page of the document. And then there is the second page or the second half of the document, which is the solution part, right? So what do we write there? How do we approach coming up with the content for that part?
Okay, so one thing is you start with very typical primitives that are related to machine learning. Like, what is your baseline? What is your metrics? Those are two things that we already covered. And you cannot really build something without having a solid baseline, because otherwise you don't know what to compare with. Once you have it, you can draft what is your next solution, your minimum solution that is better than baseline, and you are actually going to build. It's very likely that it is not just a single model. It's some kind of pipeline of things, interconnected blocks, components, and so on and so forth. What of these components are your responsibility and what components you are expecting from some other people? How they are interconnected? What is their API? I do not say you should directly describe that your microservice is going to query that microservice with this request payload. No, it can be written later, but that's not a goal of design document. You need to understand, well, do we send data to these guys in a batch, or you do it on per request in real time? Do you have some kind of queue for this data or not? So very high level interaction with external components. You definitely should mention some data related aspects of the problem. Like, do you already have data? How are you going to, if you have data, you're lucky, of course. If not, how are you going to get this data? And getting the data itself, it can be like the biggest problem, and it can be like 90% of solution. But if you are lucky and everything is in place, like how you going to process the data? Is it ready to go? Does it need some preparation, filtering, some feature engineering if you are working with classical machine learning? Or sometimes in deep learning, you can have feature engineering as well. Does it need some specific transformation? Like, well, we have this data, but it lies somewhere in data lake, which is barely accessible, and we have many problems related to fetching this data, both technical and organizational. So do we need to address them as well? And how you are going to make this whole system work? Like, okay, we have some baseline, we have some solution, like we will train model X and we will interconnect it with database Y, and it will be connected on some protocol, and we are going to evaluate it with some internal metrics and some external like A/B or something, and this is our criteria of success. And if things do not go like we expected, we are going to look here, 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 like error analysis stuff. Again, in startups, it's very rare that you have everything in place in your first run of the design document. It happens sometimes, but that's not about 2-page document we were discussing in the very beginning. If you have that many sections, it means the document is already like 20 pages, and usually it evolves. Design document doesn't have to be a static thing set in stone. You start with something small, and later you add missing parts. You collaborate with your peers. You discuss stuff. You reveal new pieces of this hidden information of unknown unknowns, and you fill the gaps.
Okay, so from what I understood, like as a short summary, there should be, first we start with describing the baseline, what is already there, or what we can build super quickly to have a number to relate to, right? Because we want to build something and we want to understand if we actually manage to improve or like build something useful. And for that, we always need to have a metric and baseline we compare to, right? That's the first step. Then you start creating a diagram. In this diagram, you outline all the things and how they are connected, like how the data flows. Like, for example, there is a mobile device. From this mobile device, the data, like these pictures come to, I don't know, this big box that we call model, right? The model is doing something and then sends back something else, right? Maybe a frame with a shoe on that, right? And then there are some other things, like you mentioned, extrapolation, or like when you don't put the shoe like in every frame, but maybe like to save battery, like you do something, right? So there could be some components that, one component is actually putting the shoe, the other component is doing the extrapolation, and then maybe there is a third component that, I don't know, is doing something else. So you put all these things in a diagram, like using a Google document or Miro or whatever diagramming tool. And then there you see what kind of data you need, right? So what kind of data flows in through your system, and what kind of data you need, I guess, for training the model too, because like maybe that's a separate diagram that describes how
Absolutely.
exactly the model. And then when you do this, you see like all the dependencies, and you see what are your dependencies, you see what are the other dependencies, you see what kind of data you need, and based on that you can understand, do we have data? Is this data easy to access? And then I guess this is like continuation. You can have a section in the solution that describes all the data issues and all the challenges that might arise, right? And that's more or less the solution, right? Did I miss anything else?
Nothing significant. Always there are details, and I'm pretty sure I missed some details when answering your original question, but that's why we are writing the book, to try to catch as more details as we know.
Yeah, so about this book, what actually motivated you to write this? What kind of problems did you see in the industry that you thought of them and understood, okay, like there is no good description of this. I need to write a book about that. So how did it happen to you? What motivated you?
Actually, I think there are many people in the industry who are smarter than myself, better engineers than myself, but who do not always see the forest behind the trees. Like you can find a person who writes better code, less bugs, twice faster than myself, know all the algorithms in the world, reads fresh papers every day, like perfect candidate. But when you delegate a big system to this person, they fail for some reason. And that sucks. That's unfair. This person should build something twice better than myself, 10 times better than myself. But sometimes they do not. So we would like to convert people who know a lot of stuff, but they don't have this holistic overview to people who can build nice, reliable systems.
Mm-hmm. So that was your main motivation. So you saw that this thing is happening in practice. There are people who are very smart, but they don't have maybe the framework or knowledge of all the things we just discussed. Maybe, like for example, if I work as a data scientist or ML engineer, as an engineer, I'm more solution driven, right? So for me, it would be, okay, there is this problem. Like I spent 5 minutes talking to a product manager. It seems I understood it. Like it's simple. I just need to put shoes on a frame, right? And then that's it. So let's start coding. And then 2 weeks later, 1 month later, or I don't know, half a year later, it turns out that I misunderstood some parts and then I built something completely useless. Right?
It happens. It happened to me as well in the past. And again, we described it in the book. And it's very often that experienced people are valuable for organizations exactly because of their bad experience. Like they did some bad job a while ago and they will not do it again. They don't want to repeat their own mistakes. And generalizing this experience is what make these people valuable. Like, okay, I know it doesn't work for me and it didn't work for my friend in other organization. And those people can make better decisions when building complicated systems. And that's a generalized experience, crystallized one. Actually, while writing this book, I had to generalize a lot of my experience as well. Because let's say I'm writing a chapter about data sets. And I definitely understand that there's always a question, how much data do we need for this particular problem? And usually I'm saying, I have some intuition, how much data I should have for this or that problem, but I don't know how it works in my head. I need to try to generalize it. I need to try to give some wording that can be transmitted from me to other person. And at this point, I realize that I don't really know. There are some heuristics, but they are not universal. And very often, I don't have a significant ground to say why we need X data for this problem. It's painful, to be honest, but it was valuable for me. And I hope it will be valuable for readers because I had to think a lot about my own experience and asking buddies around, like, okay, when you have this problem, how do you approach it? And I realized that, well, I had one perspective, another perspective, and I have seen some additional one, but maybe that's not everything. It still doesn't fit like a full picture. I'm definitely missing something. So I go read internet, I annoy other experienced people, and I realized that, holy shit, I missed a lot. That's definitely just my very, very narrow perspective. And people do it in a completely different way. And I need to learn from them, discuss with them. And later, that's just like 2 sentences of crystallized experience. That hurts, but I believe it is useful.
Mm-hmm. Okay. Yeah, and I was going to ask you if you know any good examples of a design document, but then I opened the table of contents of your book and I see that the chapter 4 is called design document. Can I assume that there is an example in this chapter?
So at some point, we decided to do 2 examples of 2 systems, both imaginary systems, non-existent ones, and we split them chapter by chapter. So our book is structured in the following way. We have 16 chapters, and first 4 chapters are introductory, more about problem statement and how important it is to understand the problem and how to do this preliminary research on the problem. And starting from the chapter 4, we effectively introduce 2 systems. One is about dynamic pricing for the retail company, imaginary company. Yeah, super mega retail. And another one is about imaginary company named Photostock that needs to build a search engine for their photos. And for every chapter later, we write a small piece of this design doc related to this chapter. Like we have a chapter on datasets, and this we write a small piece, like half page or page. What should we do to gather relevant data to build a search engine for Photostock Incorporated? Or the next chapter is metrics and losses. And here we write down how would we approach the problem of building the metrics and losses for search engine in the imaginary company Photostock Incorporated. And that's till the very end.
Okay, so then at the end, I guess the main outcome for me as a reader, I will learn how to build, how to write these design docs, right?
That's, again, a tricky question. From what we have seen among our early readers, about maybe there are 2 different patterns, 2 different modes of readers. Some people say, screw these examples. They are boring and not relevant. I don't really care. I don't want to read it. I don't like it. But the rest of material is nice. I enjoy it. It is interesting. It's going to bring a lot of value for me. And other people say, well, this is boring. All this theoretic stuff and cool stories from your experience is not any relevant. It does not help at all. But this design document on super mega retail is nice. It brings a lot for me. So I cannot say it is universal, but for some people, it works.
I guess it's hard to satisfy everyone, right? So everyone.
Oh, yeah, indeed.
And maybe this is another challenge for you because you're writing with a co-author, right? And then you might not necessarily agree on everything, right? And then maybe you also have a similar situation when you need to decide what to include, what not to include, right? Or you always agreed on everything?
Oh, definitely not. But our experience is very different. So my co-author is a person with very successful corporate career. And he's like, his last position is VP of data science. So he's a big guy. I'm not a big guy at all.
In all senses.
I prefer granting stuff hands-on. And those our perspectives are very different. And there are things I don't really know. And here, I definitely don't want to lead. I don't want to be a driver for this chapter. Maybe I will bring 2 cents of my own here and there, but definitely that's not something where I'm an expert. This all yours, dude. At the same time, there are some subsets where I feel expertful. Like I have written many training pipelines in my life, and it makes sense that the chapter about training pipelines is written mostly by myself. And that's how we find the balance between different perspectives. And with these design doc examples, again, we write them, we split them between us. Like I am writing about this photo stock, and Valery is writing about this super mega retail because he has some experience in retail, and I decided to choose something closer to my experience. I never built a search engine, but I think I understand how it could be built given some other experience in small companies related to computer vision and natural language.
So for you, it's also like a kind of situation where you need to deal a problem that you don't necessarily know in like all these unknown unknowns and known unknowns, but you approach it with this, as an engineer who needs to solve this problem, right? And then you show how exactly to build this design document.
Yes, that's right. I think, first of all, it is not really possible to write down about stuff that I built in my previous experience because of NDA and stuff. Yeah. And from other perspective, we would like to, I would like to write a document how I would have written it on my own without a deep understanding of situation. Because, well, that's what I would expect from my readers as well.
And I am a book author myself, and for me the most difficult part was to decide what I should include in the book and what I should exclude from the book, what I should definitely not include. And also the challenge was that this thing was changing as I was writing the book. So at the beginning I thought I should definitely include this, but as I was writing then I realized, okay, I actually need to split this chapter and then I need to remove this chapter because nobody cares about that actually. So how did this process go for you? Like, how did you understand what exactly you want to put in the table of contents? How did you come up with this outline? What did you use in making these decisions?
Many things changed. So first of all, we wanted to cover like everything related. And at some point, we realized that if we include everything that we planned first, the book will be twice bigger than expected by the publisher, and it will take 4 times longer than expected by the publisher. So that's constraints again. Actually, you can treat writing a book as a project of its own with all the stuff, and outline of the book is kind of design doc for the book. So we got some regularization, some constraints driven by the publisher. And while writing the text, we had some early feedback, from our friends. We sometimes share this or that chapter with a domain expert. Like if there is an expert in some particular area, that would be definitely useful to share the very raw draft with them to get some high-level feedback. Also, we have some feedback from earlier reviewers, and it is informative as well. Sometimes it's kind of controversial, like you can have one paragraph with 2 comments. One person saying, wow, that's nice, that's mind-blowing, very interesting, very valuable. And another, what the hell is it? That's definitely not interesting, just piece of shit. Why did you even write it? And
was it a quote? Or
sorry?
It was more like, was it a quote?
Almost.
Like, okay.
We had one reviewer who shitted all over the book. Like at the chapter number 3, they wrote like, well, after these 3 chapters, I tried to do my best to read through this writing, but I cannot do it anymore. It's too boring and useless. Well,
and then for those
it happens.
Because like with video, Arseny, you just made air quotes around writing for those who don't, who just hear this as in audio only version. Yeah, so writing was in air quotes. Yeah, that must be tough. Like, how do you deal with this sort of feedback? Like, do you it's hard not to take this personally, right? So then you start questioning yourself, or not really.
Actually, I started. I'm not too confident person, especially when we are talking about this kind of work. But after some discussions with my co-author and with our publisher, I realized that it is actually good if we have like more than 10 early reviewers for this stage, and there is one person who is not happy and the rest of people are happy, and most of criticism is not related to our writing, but more related to how stuff is formatted or how illustrations are made. Well, this is good feedback, and I'm not a dollar bill to be loved by everyone.
Mm-hmm.
So yeah,
So that's a good way of approaching any criticism, I guess. Just think about other things. And we still have time, like 4 minutes. So in these 4 minutes, maybe I want to ask you, pick any chapter that you liked most working on and tell us about this chapter. And then second, so we're mindful of time, is maybe you can give us some extra recommendations apart from your book that people can read or listen or watch to improve their system design knowledge. So let's start with the first one. Tell us about the chapter you liked working on.
I think so far I enjoyed writing chapter number 3 about preliminary research. That's not something that is widely covered by existing literature, I believe, because most of textbooks related to machine learning, they are about how to build models, how to run models, how to embed them into your inference pipeline, whatever. And there are some problems, there are some materials about how to frame the initial problem, how to scope the project, like all this project and product manager stuff, but not many materials. How do you start working with it? Where should you find your inspiration? You definitely don't want to build everything from the very scratch. You need to understand what you reuse, what you build from scratch, what you buy as an existing maybe SaaS solution, what you buy as a data set, where you see how people approach this problem. This was a chapter where I had to think a lot because, well, I definitely have been doing this stuff for previous projects in my career, but I never generalized them. So a while ago in this podcast, I've been whining how hard it is to generalize. And I think this chapter was the most complicated, trying to understand, well, I know what I would do for any specific project. I don't know how would I approach the project. I don't know. So it's kind of meta.
Yeah. And the other thing, so can you give us any recommendation on any resource that could also be useful if we want to learn more about machine learning system design? Do you know of anything?
Well, there are some things that are transferable from regular software system design to machine learning system design. And it's less about technical stuff, but more about the mindset, how you should frame the problem and how you should approach the problem. I totally love the guide by the Interview and IO guys. I think I can post the link later.
Yeah, please send it.
Yeah, this guide is about regular system design, but first of all, you cannot build a machine learning system design if you are not able to build at some point a software system. They are interconnected. In our book, we focus more on machine learning aspect of things, but good machine learning engineer is definitely a good software engineer as well. And there's at least some surface level skill in building regular software system is essential. We do not focus on it in the book because definitely we are not experts there. we have some knowledge, but it's not the level of knowledge we can teach other people. And that's why I would recommend this guide.
Thank you. And before we wrap up, I want to mention a few things. So we ran a giveaway on Twitter. So for those who took part, I will announce that the winners right now. After we finish this conversation, I will click the tweet button. So there are 3 winners. You will get a free copy of the book. And also for those who are interested in the book, I put the link in the description. And also Mining was kind enough to give us, our podcast, a discount, 35% off. So there is a coupon code there for the discount. So if you're interested, check it out. And I think with that, that's all we have time for today. So Arseny, thanks a lot for joining us today, for sharing your knowledge, for talking about the book. And thanks everyone too for joining us today, for listening in. And yeah, I guess that's all for today.
Thanks. It was a really fun podcast.
Happy to hear that. Okay, well, enjoy the rest of